Let's try to start the stream again. Let's see how this goes. It's working. Hello, 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 hello. Let's try to start the stream again. Okay, it's working. Sweet. So, sorry about that. That was odd. I think it's working now. So let me go into the next question. So I spent like an hour looking at this spiral matrix question. This is an interesting question. Let's go to the next one. Subsets already solved that one the other day. Find the winner of the circular game. Okay, there are n friends that are playing a game. The friends are sitting in a circle and are numbered from 1 to n in clockwise order. More formally, moving clockwise. Let me also, actually, I need to check something here. Let me get the chat. I forgot to get the chat. There's actually one more element here, and that is I gotta plug this in. The friends are sitting in a circle and are numbered from 1 to n in clockwise order. More formally, moving clockwise from the ith friend brings you to the ith plus 1th friend. For 1 less than or equal to I less than n, and moving clockwise from the nth friend brings you to the first friend. Okay, so it's circular. Start at the first, count the next k friends in the clockwise direction, including the friend you started at. The counting wraps around the circle and may count some friends more than once. The last friend you counted leaves the circle and loses the game. And there's still more. One friend in the circle. Go back to step 2. Starting from the friend immediately clockwise of the friend who just lost, and repeat. Else the last friend in the circle wins the game. Given the number of friends n and integer k, return the winner of the game. Okay, this is an interesting question. What are the constraints? Between 500, solve it in linear time with a constant space. Yeah, I think you could. This is not such an obvious question. I bet you this question has a constant time solution. It's more of a math question. Give me one moment. I need to think about this one, though. Think of a solution that's quick, and also think about a solution that might be like constant time or logarithmic time. The stream ended unexpectedly. What's up, Yash? Yeah, I did. Yeah, I restarted it. I had my internet dropped. I think eventually I'm going to need to get a better internet connection. Although that might be a while. That might be some time. We'll see how long it takes. Let me see. Okay, hold on one second. I'll be right back. Okay, back. So I could always simulate this solution, but they were suggesting that this would not be linear time, which it would not be. There's also probably a way to do this that's like more of a math-based solution. Let's try Excalidraw, see if I can come in and get anything interesting here. Try to see if I can find some patterns. All right. So let's say we had like 1, 2, 3, 4, 5, 6, 7. And let's say, let's make it a little more complex. Let's go to like 8. And then we want to say, all right, with 8 nodes in a circular array, let's do k is like 4. So we do 1, 2, 3, 4. They have examples here too. So example 1, they have 5 and 2. So 1, 2 is deleted. Then start off at 3, 3, 4, 4 is deleted. Start off at 5, 1, 3, 3 is deleted. Oh, excuse me. Oh, okay. From 4, you go to 5, 1. 1 is then deleted. Then you go 3 to 5. 5 is deleted. And then 3 is left. So in that case, so let's actually just quickly go through that one first. So they're saying in case 2, first iteration, you're going to eliminate 2 and then be at 3. Start at 1, eliminate 2, and then end up at 3. Then eliminate 4, end up at 5. Then, is that right? 2, 4, 1. No, did it wrong. So 1, start at 1, go to 2, delete 2. Then you're at 3. Go to 4 and delete 4. Now you're at 5. But you're only moving over 5, 1. So you delete 1 and end up at 3. And then you would delete 5. End up at 3 again. So you delete 2, then 4. Okay. And then it's circular. You could push 1 and 3 here. So you have 5, 1, 3. You delete 5, or excuse me, delete. Oh, interesting. You would delete 1. And then move the 5 to the right of 3. I want to say that I could use like modular arithmetic. At each pass, I would delete or mark like every odd value or something. Could simulate this using a linked list. That's probably the easiest way to do it. This is very similar to, and it's not, no, never mind. It's not the Josephus. I was going to say this is maybe similar to the Josephus question, but it's not. Let's think if there's like a pattern that we could exploit here. So when k is 4, we're going to eliminate 0, 1, 2, 3, and then 0, 1, 2, 3. Yeah. And then we end up at 8. We actually end up at, in this case, we end up at the beginning of the array again. We get rid of 5. And then 1, 2, 3, 4. I think we get rid of 3 next. This would end up being 6, 7, 1, 2, 3 is kind of how I would think about it. And then here we would delete 2. So 6, 7, 1, 3. And it actually becomes 3, 6, 7, 1. would then delete 1, end up with 3, 6, 7. And then it would be 0, 1, 2, 3, would delete 3, I think. And then it would be 0, 1, 2, 3, would delete 7. So is 8 and 4 6? So one of the questions. Okay. It is 6. Okay, so I did that correctly, or I got the right answer. I may or may not have done it correctly. I seem to have the right idea as far as like how this works, sort of. Okay, let's try some other examples. So what do we actually? Let's do some analysis here. What do we remove? What was the sequence? We removed 4, then 8, then 5, then 2, 1, 3, 7. 4, 8, 5, 2, 1, 3, 7. Seems almost random what all these elements that were removed were. Is there a pattern? Is there a sequence? Something I can grasp onto, something I can understand here. Well, I could take the number of nodes divided by 2, or divided by k, and figure out how many nodes will be removed at each iteration. That's fair. Round it up to 1. It's always at least 1 node. Which node is it? And it's circular, so the positions of the nodes change too, which is a little bit odd. Um, Interesting question. Can it be done in constant time? Constant time. It's very similar to linear probing. like it would be 4, then 8, and then I would normally jump back to 4, but 4 was removed, so I would jump to 5, and then I would jump to 9, which is 1, which I think I do. Oh no, I end up actually at 2. Oh yeah, it's because 8 was removed too. So end up at 2 rather than 1. Because 4, 1, 2, 3, 4 would actually go to 2, not to 1. So you add another 1. So it'd be like you jump 5 instead of 4. And then jumping again 4. There are now 2 things that are removed. So you end up in that section. So you end up actually at 7. No. When 2 is removed, what do we end up with? Now you moved to 3. And you do 4. 1, 2, 3, 4. It's not 7. 1, 2, 3, 4 would be 6, but we've got to move over 1 to 7, move another 1 to 8, which would be 5. The 4 and the 5 that are missing. Then move over another 1 because 8 is missing, and up at 1. 2 jumps all the way back to 1. And then move back to 3 again. We would do 4 again, but it's 1. That's removed. That's removed. 1 is 6. 7's removed. Oh no. Yeah. Well, I don't know. 1, 2, removed, removed, removed. 3, 4. 1, 2, 3, 4. Oh yeah. Okay. So the fourth one is 3. So 3 removes itself. And now we're on 6. We go 6, 7, 6, 7. And remove 7. I mean that's odd, huh? That's a bit odd. Oh boy. Oof. Okay. Yeah, I don't know about this one. I'm looking for ideas and patterns. I'm not seeing too many things I could use. Sure, I was smart enough or experienced enough to put forward my own opinions. I'm not able to grasp the whole concept, but parts of it. I think I need to spend more time on practicing. Yeah, yeah. I mean, it's not too bad. It's I mean, in this case, the simulation is fine. Like the constraints are pretty low on this one, 500 by 500. So it is possible to solve it with a simulation, but the linear time and constant space approach is not so obvious. I suspect that you could do it even faster than linear time, by the way, but that's a little more complex, I think. It's not obvious how to do that. Excuse me. Just thinking of different ideas that could be helpful here. Let me try a different question, see if I see some pattern. I have to remember to do it the other way around. Let's do like 9. Let's do k is like 5. So we do 1, 2, 3, 4. 5 would be deleted. 6, 7, 8, 9. So 5 is deleted. I end up at 6. And then we do, whoops. 6, 7, 8, 9, and the 1 gets deleted. and we would end up at 2. If 1, 2, 3, 4, 5, 7 gets deleted. We end up at 8. And then we have 1, 2, 3, 4, 5. We get 4 is deleted. Which then starts off at 6. And we do 1, 2, 3, 4. 1, 2, 3, 4, 5. 3 gets deleted. And 3 ends up at 6. 6, 7, 1, 2, 3, 4, 5. Looks like 6 gets deleted next. And we end up at 8. And then we have 1, 2, 3, 4, 5. We end up with 9. And that's deleted. Which then we end up at 2. 1, 2, 3, 4, 5. We delete 2. So the sequence of deletions is 5, 1, 7, 4, 3, 6, 9, 2. And we end up at 8. Do we get 8 as the solution of this one? So that's if I were to simulate it. That's what I would get. 9 and 5 should be 8. Oops. Okay, let's see if I do get 8. It's just a test to see if I'm on the right track here. Expected 8. Okay. All right. So pretty interesting. Is there any way that I can optimize this so that I can make this faster, easier? Any kind of insight that could be helpful here? Well, what's awkward about this is that I'm going to be removing elements from this data structure, and then I'm counting something across that data structure that's being modified, that's changing, which is a bit awkward, to say the least. Excuse me. It's clear that there's going to be at least one element left at the end of these operations. That's fair. That's true. But which element is the one they want to know? Yeah. Yeah, very interesting. There's some ideas I'm thinking of here, like I mean, a simple n times k solution that uses uses n extra memory would be to do exactly what I just did, where I just move across 5 times, select this spot, mark that as seen, and then move another 5 times with modular arithmetic, and then if I reach something that was already seen, it would just increment past it. It's not efficient, but it's one way of doing it. Gives us O of n times k time, which would be sufficient for the constraints. Yeah. And there would be O of n extra memory, but it's not what they're looking for, O of n and no extra memory, which is a lot faster. Excuse me. Hmm. Sorry, I'm suddenly getting very tired. Yeah, I'd have to sit and ponder this for a while. I wonder if I could use a summation. Like if I took the sum over 1 to n and then I just removed the numbers that are going to be removed at each iteration, each step. I wonder if that's meaningful here. Maybe. Hmm. So I'm starting to like fall asleep over here thinking about this question. About things that could be helpful here. Yeah, I'm really tired. Suddenly very tired. Hmm. Yeah, I don't see a solution. Also, my mind is drifting elsewhere, which is not really good. Hmm. I'll just kind of ponder this and think about it a little bit more. Think about it a little bit more. Sometimes it feels like you will leave this mortal world and become an immortal. Tired, go ahead and rest. It's really important. Yeah, it is important. Leave the world, become immortal. Yeah, man, it's possible. I think I'll probably make a video on that of this idea of like there's reproductive strategies and there's regeneration strategies for life, and most of life on Earth goes through reproductive strategies, but actually it may technically be possible to approach a regenerative strategy, which is really it's extremely rare, but may technically be possible on a scientific level. Yeah, this is one of those harder questions. It requires some deeper insights, I think. I have to ponder this for a while. Maybe generate some more data, see if I see a pattern. I don't see anything. Well, if there's something there, it's not easy to see. It's not easy to spot. Let's go with 10 and 3. So remove a 3, 6, and a 9. Yeah. Then, so 3, 6, and 9 is gone. Look at 10, 11, 2, 4, 5, 7, 8, 10, 1. 2 and 7, I think, are removed next. And then, yeah, 8, 10, 1 is removed. 4, 5, 8 is removed. And then 5 is removed. 10, 4, 5. And then maybe at 10, you remove 10 and 4. 10, 4, 10. All right. So I think 10 and 3 should be 4. Oops. Expected 4. Yeah. Okay. Where is okay, yeah, looks the stream is fine. Okay. Maybe I could do some other data. Let's remove these. Let's just go with 10. 1, 2, 3, 4, oops, 5, 6, 7, and 8. One, two, three, four, five, six, seven, 8. Helps to look for patterns. Okay. Let's see what numbers we get. So I got 10, 5, 10, 5, 4, 5, 3, 3, 7, and 8. We got 9, 1. And then so 9 is 7 and 10 is 8. Okay. So these are the numbers that I get when I scroll, when I move from 1 to 10, n is 10 and k is 1 through 10. 10, 5, 4, 5, 3, 3, 9, 7, 8. Yeah, these are pretty varied. There's no obvious pattern going on there. Hmm. 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 Okay, I'm falling asleep over here for sure. Maybe I'll just take a break here. Um, yeah, I mean, I could simulate this. It'll work. I spent about an hour looking at this now. Um, yeah, I am kind of just falling asleep over here. I don't think hmm. It's a tricky question, man. It's a tricky question. Hmm. The first pass is going to delete the like 369, the multiples of k. That's always true. And the second path, there's some modulo amount that's offset by, but you would delete, in this case, it's offset by 1, you delete 4, and then 10. Is that right? 10, 1, 4. Did I calculate this correctly? Feels like I did not calculate this one correctly. Oh, excuse me, I would delete 2. Okay, forgive me. Yeah, it deletes 2 and then 7. Hmm. If I were to start from 1 again, it would be 4 and 8. So 369, and then becomes 4 and 8. And it's offset by 1. So it actually decrements down to 2 and 7. Huh. Gee. So you'd subtract 1 to get you 2. Instead of 3, you get 2. And then you've deleted 4 and 6. So when you add 3 to 5, you actually end up with 2 more. Ends up at 7. And then the next value you're starting at then is 8. 9 was deleted. So you'd sort of start at the beginning again, but plus 2, shifted by 2. And so your starting point is just 1. So you delete 1 and 8. And then start off at 10 again, delete the 5. Huh. This is an interesting question. Not so easy, but interesting. Rise and shine. Yeah, thank you. I'm like falling asleep over here. Looking for patterns. I probably should take a break and go to sleep. I think I'll do that in, whoops. I think I'll do that in maybe like 30 minutes. I'll take a break. I maybe should reset this to, this is actually just this problem. Now that I'm working on this one, it's just this one. So as I said before, I could simulate this. It'll work in the time bounds, but there's clearly a linear time solution that they're looking for, and then there's also potentially faster solution. Maybe there's a logarithmic solution. So sometimes trying to find the constant time solution is a little bit of a waste of time. And instead, maybe either a logarithmic or linear is better. That might be part of where I'm getting it wrong. This doesn't seem to lend itself nicely to a logarithmic solution. I don't see a way that I could remove a logarithmic number of nodes each iteration. Not so sure about that. Clearly, I can use I might be able to use a prefix sum of some sort or an interval tree or something to figure out how many nodes I've deleted in a specific range, to figure out how far I should extend that range modulo 10. And so I can kind of immediately figure out which node needs to be deleted next. But the problem with that is it doesn't use a constant, doesn't use constant space, but would use potentially linear space. That might be O of n time and O of n space, maybe. I mean, using a BIT, I think I can get O of n log n time and O of n space. But that's still not what we're looking for here. Basically, the idea is just figuring out which is the next node that I would delete. At each step. Yeah, I mean, simply put, for each element that I've deleted, I would just increase the range. That's how far I would need to go at each step. That's simple enough. How can I easily figure out how many nodes I've deleted already? Especially doing it with constant time. Huh. Gotta think about that, huh? Oh, excuse me. Yeah, I mean, definitely an O of n times k with n extra memory is possible. As I mentioned, I could just go one by one. Um, Let me program that just so I have that. It's not great, but it's doable. Actually, it should. I'm just going to scale all these n values down to zero indexed to keep it simple. Um, it's something like this. It's maybe not the best way to program this. So the idea would be, let's do it zero indexed, and we're going to say count plus one's less than n, keep incrementing the count. I'm going to start with I is 0 and increment it up to k, and then also increment the current position. And if the position we're looking at, the current position, has been removed already, then we're going to decrement I. And then after we've shifted current to the right spot, we remove current. And then we also increment current. Forgot that part. Does that work correctly? If I ran this through on an example, it would be 0 through 9, for example. And I would start with 0, and if k is 3, I would jump 1, 2, 3 to 4, I think. So after k minus 1, I think. Yeah, k is 3, be 0, 1, 2, be 3 times. And this would increment 3 times. In that case, 0 would increment 3 times. Or this index would increment 3 times. Which actually might not be correct. I think it's 1 less. Still wrong. So we'd start from 0, and we would go, k is 3, 1, 2, 3, which is not the right spot. We would want to go to 0, 1, 2, and remove that. And then increment 1 more to 3. Then go 3, 4, 5, and remove that one. And then 6, 7, 8, and remove 8, I think. If we incremented by 1, it'd be 3, 6, and 9. Yeah. Let me just print these. I maybe should do this a little bit better so that way it's a little easier to understand what's going on. There's probably a better way to do this, a little clearer. 8, 7 across the board. That's not correct, huh? Huh. Starts off at 8. What? Oh, I'm testing on the wrong case. Case 3 is the one I want to look at. Two, 5, 8. Okay, that's a little bit better. 2, 5, 8, 1, 5, 8, 1, 5, 8. Okay. C++, nope. What's up, Sari? Hope your day's going well. Welcome, welcome. C++ is great. C++ is great. 0, 1, 3, 4, 6, 7, 9. This is going to be after the deletion. So I would be at 9, and I would go 9, 0, 1. And then should be 1, 2, 3, right? Yeah. So it should be 6. Should be 1, 6, 0, 3, 4, 7, 9. So I get 1, 5, 8 again. Huh. But I could also just print current at each step. Zero, 1, 3, 3, 4, 6, 6, 7, 9, 9, 0. Oh, I don't think I need this one. Oh, interesting. I'm not sure now. Zero, 1, 2, 2, 3, 4, 3, 2, 3, 4, 5, 5, 6, 7, 8. So 2, 5, and 8. Then 8, 9, 0, 1. 1, 2, 3, 4, 5, 5. It's not quite right. Something's not right here. I mean, I could do it the other way around. This might be, I mean, I think it does the same thing, but it's a little bit easier to understand. Yeah, it does the same thing. I don't know. Including the position itself. This is a little bit confusing. Two, 5, 8, 1, 5, 8. Okay. So 2, 5, 8 is correct, but then, and then 1 is correct, but then it goes back to 5. And it should go to, I think, 6, not 5. 9, 0, 1. And then it's supposed to jump over from 1. Which is confusing. 369. 369, 269. So we get 1, and then when this iterates again, k is 3, I is 2, 2, 1, it jumps 2 more times from 1, jumps 2 more times from 1 to should be 1 time, 2 times to 4, and then 5. And it's supposed to keep going from 5. Oh. Okay. That might be the issue. That's a little bit confusing. Nope, still does the same thing. It's the same logic. But why, maybe this is what I should do. No. 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 Huh. It's a little bit better. So 258, then we get 1, 6, which is what I expect. Then we get should be at 7, 7, 9, 0. Then 3, 4, 7. I think, right? 7, 9, 0. Jumps to 3, 3, 4, 7. That's correct. 3, 4, 9. From 9 goes to 9, 3, 4. Excuse me. And then that's 3, 9. This is from 9. It goes 9, 3, 9 again. And we're left with 3, which you add 1, we get 4. I think the result is supposed to be, give me 1 second, folks. I'll come back in a moment. I think the answer is supposed to be 4. Yeah. So I'm doing something wrong here with this program. 15, learned coding when I was 12, made a simple game using Unity. All this before AI was a thing, and for the last 2 to 3 years, I haven't touched coding. 2 to 3 years, I haven't touched coding. What? So, a ditchy gamer. If you're 15 and you programmed when you're 12, but you haven't programmed in 3 years, how? 15 minus 12 is 3, man. So, what is your question, Aditya? Do you want to code again? Or are you asking for some tips? Well, what's up, man? I guess maybe it's more like 2.5 years you haven't programmed for, something like that. Interesting. Interesting. So my output is, it should be 2581607. 2581607. Okay, and then 4949. Oh yeah, that's right. Okay, so I have the right outputs. Right, actually, it's the logic looks like it's somewhat correct now, but I get an output of 1 instead of 4. Now it would be 3, I think. So what is it's the result now? Feels like this program should be a lot simpler, a lot easier to program. Result of 0 now. Oh, I know why. I know why. That's confusing, huh? There we go. This is very silly, man. I don't know. I don't know about this one. This is a bit wonky. There's probably a better way to do this. Also, I might run into some issues if I try to do this. Let's see if I get everything right. I got it. Okay. I mean, we got there, but that doesn't feel good at all, does it? It definitely feels like this took way longer to program than it should have, and also this is not the best solution, the optimal solution. It's not really good to like sit and spin your wheels thinking about something if it's not too obvious. Jeez. Yeah, I don't like this, so I programmed this. This is not great. It's okay, but it's not great. But this is the basis for like at least one algorithm that could work. Jeez, man. Jeez. Okay. Yay, bro. Can you try 3889? I could. What's up, Rudra? Yeah, we could do 3889. Before we do that though, let's look at one of the best solutions for this problem. So there are other possibilities here. I didn't come up with the the linear time constant space solution. That's okay. We got a solution. We could look at the submissions. It's probably not a good idea to it's probably not a good idea for me to spend too much time trying to figure out like the best way to do this. Okay. So they said, interesting. They said if n is 1, return 0. Otherwise, return solution of n minus 1 k plus k mod n. N k plus 1. Oh, that's interesting. N minus was 1 k plus k mod n. Oh, that's an interesting idea. Huh. Let's try that. I think of doing that. Oh, it's kind of like dynamic programming. Okay. Yeah, like I said, it's not a great idea to waste too much time if you don't see the answer. Especially when I'm like falling asleep over here. I think, hold on, what did they do? Okay, so they said this would be like a for loop. Let's say previous is like solution, or just a calc n minus 1k. And then we're going to say previous plus k mod n. Okay. So if I wanted to do like int I equals 0, I equals 1, I is less than or equal to n. So if n were 2, for example, or n was 3, if n was 3, we would do solution or calculation of 2k plus k mod n. And then that would be n equals 2. Similarly, calc 1k plus k mod n. And then equals 1 is just 1. Or no, excuse me, it's 0. So I have 0 plus k mod n. And then this is k mod n plus k mod n. Also, it's missing parentheses there. So we start off at 0. And say, okay, at the next iteration, we're going to add k mod 2. Or mod n. And then we're going to take the previous result and do the same thing. Is that it? Is that what we need? And then we will return at the end of it the result plus 1. That seems very odd. If that's the solution, I'd be kind of shocked. It's that simple. Oh. Wrong. Doesn't seem right at all. What did they... How does this work? It's the previous solution plus k mod n. Could remove k in all these cases except for just adding k. I might be doing too many of these, actually. That might be the issue. I probably should try to understand what's going on here. Let's try again. N is 1, we return 0. So this should be less than n. If n is 2, we would return 0 plus k mod n. So if n were 2, be k mod n. Okay. If n were 3, we would do k mod n, which I got, and then the next iteration would do add k again to that and take mod n. Yeah. Is this even a correct answer? This seems to take that recursive solution and convert it to an iterative solution. Maybe I'm wrong. It is the correct answer. My conversion's wrong, though. I'm not sure why. I have your stream running on one tab and I'm coding myself. It feels like I have company. It's kind of fun. Cool. Yeah, I'll try 3889 after this. I was expecting I would be able to get this pretty quickly, so understand what's going on here pretty quickly. Yeah, this is just the previous solution plus k mod n, which it should be plus k here and then mod n. Not sure why this doesn't give me the same answer as this code. Seems like it should. Also, not obvious at all why I would just keep add k mod n repeatedly. That seems strange too. Yeah, there's definitely some mathematics involved here that's not obvious at all. Oh. Ah. I see the issue. Okay. Got it. Got it. That's pretty subtle. Okay. Got it. That's why. It's not mod n. It's mod. Oh, okay. That's what's going on here. I'm missing. Okay, that's important. That's pretty subtle. Not subtle, but it's an easy mistake to make. Got it. I'm looking at it like, wait a minute, what am I missing here? That's because n is changing at each iteration. That's why. Oh, okay. Got it. My answer's wrong, though. Yeah, that's pretty tricky, man. That's pretty tricky. Okay. Okay. So the first iteration is 0. When I is 1, it's 0. Then when I is 2, we would do add k and take mod. So in that case, but I guess this one's going backwards. Oh, it's very interesting. All right. So it's more like n equals 1, we get 0. N equals 2, we get 0 plus k modulo 2. Yeah. N equals 3 is then k mod 2 plus k mod 3. Also, I'm starting to get some pretty serious lag here. Yeah, that's the part that I was missing. That's the important. That's like critically important. And as 4, it becomes this solution plus k again mod 4. I think that's right. Also missing my parentheses here. Okay. Oh. So actually I'd want to grow the modulo value from, I don't want to decrement the modulo value, I actually want to grow the mod value. I think it starts off at 2. When I is 1, when I is 0, no, I is 1. When n is 1, we just return 0. When n is 2, I is 0 starts off at, yeah, I think it's something like this. Okay. Well, remove these. Okay. I think that's what I'm missing. It's important. Got so much lag. There we go. Yeah, it's pretty subtle. That's pretty subtle, man. Not subtle, but like it's not obvious why this would be correct. Let me try it, see if it's correct. That's a heck of a solution, right? That is really fast. Yeah, that's really fast. Okay, so that is linear with constant time. It's probably about as fast as it's gonna go. Let's think about that for a minute. Like, what is going on with this? I guess why would that work? That seems really strange that this would work this way. That it's k mod 2 result plus k mod 3 plus k mod 4, etc. That seems really odd. Which, by the way, this could probably be, you could do some math, I think, to reduce this to, like, you have multiple modulo operators happening on the first k, and then one less modulo, some series of modulo operators happening on the next k, and adding each of those values together. I suspect you could actually optimize this even further, but that's a heck of a solution, huh? I'm doing an MBA in finance and commerce background. I want to get into AI engineering. What's up, new user? Hope you're doing good. This day's going well. Welcome. Appreciate your work. Keep going. What's up, Swabnesh Swaru Mahanti? I'll just call you Swapnesh. What's up? Welcome. Yeah, I appreciate that. Appreciate that you appreciate it. Okay, it's not obvious to me at all why this is correct. Yeah. It is also still linear time though, which is also, like I said, I suspect there's a way. Oh, my computer's really lagging. How are we doing on time? An hour and 45 minutes. So I suspect there's a way to first off, why is this correct? Before we go on to, someone wanted me to look at 3889. Let's start with why is this correct? It's not obvious at all why this is correct. K mod 2 plus K mod 3 all the way up to, I think, K mod n. Add K mod n each time. Why would this be right? Well, the +1 at the end is clearly because it's 0 index and 1 index, so let's just consider from the 0 index position. So when we add k, so in this case we're adding 3, so let's look at this. Let's look at this again, 10 and 3. That's a heck of an answer, man. Heck of a question, heck of an answer. Let's try to understand it. Starting from 0, we would go to add 3 mod 2, which is then 1, for some non-obvious reason. Then we do 1 plus 3 mod 3, and that gives us 1 again. And then 1 plus 4 mod 4, no, 1 plus 3 mod 4, it brings us to 0. Then 0 plus 3 mod 5 is 3. 3 plus 3 mod 6 is back to 0. 0 plus 3 mod 7 is 3 again. 3 plus 3 mod 8 is 6. And then 6 plus 3 mod 9 is 0. And then plus 1 is 1. Well, it should be 3 though. I think I go to, mod 10 one more time. 0 plus 3 mod 10 is 3. And then 3 plus 1 is 4, which is the answer. Yeah, it's supposed to go 2 to 10, 2 to n all the way down to 2, the modular values. Why though? Why would you add k and modulo n? Or this mod value, this increasing mod value? This is a really unusual question. This is like a really peculiar solution for sure. Yeah, this is quite the thing here. Give me a moment here. Let me see. Wow. Huh. Gosh, man. Huh. Why would this even be right? That seems so odd. Front to back, back to front. Huh. Well, maybe we could prove that it's correct. Let's start with the solution to n minus 1k modulo n, right? So it's solution n minus 1k plus k modulo n. That's the solution, right? And maybe we could prove that that's the case. So let's suppose that I did solve this for 9 and 3, right? So basically saying that take n equals 10, k equals 3. It's going to be solution of 10, 9, 3 plus k mod 10. Okay. So the solution for 9, that would be 0, 1, 2 is eliminated, 3, 4, 5 is eliminated, 6, 7, 8 is eliminated, and then 9. That becomes 0, 1, 3, 4, 6, 7, 9. Starting from 9 and wrapping around, we have 9, 0, 1 is eliminated, 1, 3, 4 is eliminated, or excuse me, 6 is eliminated, and then 7, 9, 0. We would get 7, 9, 0 would be eliminated. Then 3, 4, 7 would be eliminated. Get 3, 4, 9. 9, 3, 4 would be eliminated. And then you'd have 9, 3, 9 would be eliminated. You'd end up with 3. Okay. I don't think that's right. 2, 3, 4, 5, 6, 7, 8 would be eliminated. So you end up with 0, 1, 3, 4, 6, 7, 9. Then 9, 0, 1, 3, 4, 6 would be eliminated. So you get 0, 3, 4, 7, 9, which starting out at 7, 9, you'd end up with 0 is eliminated, 7 is eliminated, and then you have 3, 4, 9, 9, 3, 4. Oh, okay. 3, 9, 9, 3, 9. Is 9, 3, 3? That doesn't seem right. That can't be right. No, it should be 0. 9, 3 should be 0. I did something wrong. Oh, this is 8, not 9. Excuse me. 10 would be oh, that's why. Duh. Okay, that's my mistake. That's a mistake on my part. There's no 9. Oh, okay. Got it. Yeah, I kind of goofed there. 0 through 9 is the same thing as 1 through 10. Shifting everything over, so it should be 0 through 8 is 9 elements. Okay, 2, 5, 8. So we would eliminate, we get 0, 1, 3, 5, 6, 7. Now 7, 0, 1. No, now it's 3. Okay, now the 3 is eliminated. And then 4, 6, 7 be eliminated. Okay, got it. 0, 1, 3 is gone now. 3 is gone, 4, 6, 7 is gone, and there's no 9. And this 7 starts off at a 1, or 0, and then 0, 1, 4. And that's what's eliminated next. 0, 1, 6. 4 is eliminated. There's 6, 0, 1. A 1 is eliminated. We have 0, 6. And we start off at 6, 6, 0, 6. There we go. Okay, yeah, it's supposed to be 0. All right, great. So what's being suggested is that if I take this previous case, which I did, I went through those 9 values, deleted everything, and I add 3 to it, and take that modulo 10, that'll give me a solution for the n plus 1 case, or the n equals 10 case. Now, why would that be the case, right? Because if I take this whole thing and I add one more element to it, and I go to 9, 9, 9, 9, 9, 9, 9, 9, right? Changes things significantly. So here, instead of 3 being removed, it would remove a 1. And a 6. And then now you have 3 and 7, right? And then instead of removing a 4, you'd remove 0 and 7. And this becomes 3, 4, 9. And starting from the 9, you have 9, 0, 1, 4. 4 gets removed, you end up with 3 and 9. And then you remove 9 and you end up with 3. And while it's correct, it's not obvious at all why these would be related to each other in that way. Wow. Sorry about that. Sometimes I hear things, I'm not sure what's happening. Okay. But why? Why would these be related to each other in that way? That seems really not obvious at all. So the solution that I get here, whatever index I get at the end of this for 10, I can add another 3 and take that modulo 10. Huh. Why might that be the case? Well, roughly the same number of nodes are eliminated in the first iteration, but the second iteration starts to really change dramatically, right? 0, 1, 3, 4, 6, 7. Why would this recurrence relation be true? All right, I think I need some help. I don't see it. Again, probably best not to waste too much time. Let's say, oops. let's go to given the above. Why would the recurrence relation solution of nk n minus 1 k plus k mod n hold extremely seems counter to none of this. Yeah, let's see what the AI says. I don't see it at all. I don't even remotely see that. Oops. Also my Sometimes get stuck, huh? Why would this recurrence hold in this case? It's a Josephus problem. It models the circular elimination process after each step. When n is 1, the survivor is at position 0. Recursive step. After eliminating the kth person in a circle of n people, the problem reduces to a circle of n minus 1 people. The survivor's position in this smaller circle is solution of n minus 1k. Reindexing. The next round starts immediately after the eliminated person, effectively rotating the circle. To map the solution from the smaller circle back to the original indexing, you shift the result forward by k positions. The modulo n ensures the indexing wraps around correctly within the bounds of the original circle. This recurrence works cleanly with 0 index positions. For 1 index results, the formula is adjusted. Is this the Josephus problem? Is it a variant of just the Josephus problem? Understanding, is that the Josephus problem? It's basically the same problem, but with k equals 2. Oh, I think they got me, man. They got me with this one. This is the Josephus problem. Okay. I've learned a little bit about the Josephus problem, but I kind of just didn't see that it was related to this. Classic version uses k equals 2. Okay. Allows for any step size. N people in a circle eliminate every kth person until 1 remains. Standard formulation of the Josephus problem for arbitrary k. Okay. It's a well-known dynamic programming solution of this general case. Excuse me, it's not a variant, it's the general form. Simpler closed form solution. Let's see. Right. Okay, so it's the Josephus problem, which is not really an ad hoc thing. It's something that it's something that what was I going to say? The Josephus problem is kind of a well-known problem, and this is just the general form of the Josephus problem. Closed form solution, any n can be written as n equals 2 to the m plus 1, 2 to the m's largest power, 2, 0 less than or equal to l less than or equal to 2 to the m. And the survivor is Josephus equals 2l plus 1. Solution for k equals 2 is simply doubling the remainder after removing the highest power of 2, then add 1. Okay, so you remove the highest power of 2, double the remainder, and then add 1. That is 41, which is 32 plus 9. And j of 41 is 2 times 9 plus 1. Oh, interesting. Oh, neat. Okay, so this is the Josephus problem, and it's definitely not something that I would like easily see. But it's not that hard to see it. So the way they explained it was that take the circle for n equals 10, k is 3. In that case, you're starting with the 0 index, and you're looking for the survivor at some final index. If you move k indices over and remove that person at that spot, now you're looking at 9 people starting at the 0 index, but you just have to adjust the index correctly now. So you'd have you could translate from one problem to the next in that way. So starting from the 0 index, the solution at basically k mod n, right? So whatever position you got, I guess starting from the 0 position, you can add k. How do you express that? It's not that the survivor's at the 0 position, like, yeah, it's not obvious at all. That's even after it's been explained, it's still pretty tricky to understand. No simple closed form solution for arbitrary k. There's for k equals 2. Approximate or asymptotic formulas for specific k and some advanced mathematical approaches provide expressions involving constants or logarithms. For k equals 3, a formula involving log 3, 2, and a constant has been derived. These are not as clean and practical as the k equals 2 case. Practice the recurrence is used, solvable in O(n) time, or more efficient algorithms exist for large fixed k. Cool. Okay, that's interesting. Can you explain again why the f of 10, 3 case comes f of 9, 3 plus k mod 10? I think I kind of get it. It's not too obvious. If I eliminate a node at position k, starting from index I, index 0, end up with an f of question, but g, in that case, the starting index is shifted. The recurrence holds because after eliminating the kth person, you're left with a smaller circle than -1 people, but the counting starts from the next person in the original circle. When you solve f of n minus 1k, it gives the survivor position in the new circle, where the next person after the eliminated one is now treated as position 0. To map this position back to the original circle, you must shift it forward by k positions because the new circle starts at k steps ahead in the original indexing. Modulo n ensures the result wraps around correctly within the bounds of the original n-person circle. So for 10.3, after removing the third person, the problem reduces to 593, but the answer from 593 is relative to the new starting point. Adding k and subtracting %10 from modulo 10, and taking modulo 10 remaps it to the original number. Okay, so I understand that the circle becomes smaller by one person. However, when I find the survivor of the smaller circle, why do I map that person's index back to the larger circle by adding k? So I guess because when I eliminate the kth person, I'm now starting at the kth position. Starts from the falling person, effectively rotating the starting point in the circle. If I understand correctly, it would be like I solve problem for the smaller circle, but with starting point as k rather than 0. Is that fair? That's exactly right. Okay. People starts counting from what was originally the k plus 1th position. When you solve f of n minus k, the result is the survivor position relative to this new starting point index as if the new starter position is 0. Adding k and taking modulo n translates that relative position back into the original circle's index. Solving this subproblem with a shifted starting point and then add k to adjust the shift. Oh, I think I understand. Okay, so whatever survivor is found starting from position k0 would just be the result will just be incremented by k in the shifted circle. Reason for this started at k rather than 0. It's really k minus 1. Means all of the indices just shifted. Okay. Actually, it's k. I think it's index k. That's really confusing. If k is the 0, 1, 2, k is 3, we're actually limiting 2. We start at index k. Yeah. Okay. So the offset, the shift, is understood as a shift in the smaller circle. However, the indices mapped into the larger circle require mod n and not mod n minus 1, since these indices are from the larger circle, not the small. Is that correct? Okay, so that's one of the parts that I'm kind of confused about. Like, Why wouldn't I do modulo n minus? Well, I kind of understand why I wouldn't do modulo n minus 1. Modulo n is used for mapping the survivor's positions from the smaller circle of n minus 1 people back to the original circle of n people. So the result must be interpreted in the context of the original size, where indices range from 0 to n minus 1, or 1 to n and 1 based indexing. Even though the subproblem is solved on a reduced circle, the final answer needs to be adjusted relative to the original circle size and indexing. Adding k shifts the position in modulo n ensures it wraps correctly within the bounds of the original and first circle. So yes, the indices belong to the larger circle, hence mod n. Oh, it's very interesting. Okay, so I solve for the smaller subproblem. Then I can shift the indices subproblem to get correct index of the survivor, as if I had started from a different. Okay, however, those indices are potentially side of 0 down minus 1, n minus 2, and further, index of the survivor should be from the larger circle, not smaller circle. Take mod n rather than mod n minus 1. Bring those indices to properly wrap those indices. Huh. Solving the subproblem of size n minus 1, the result gives the survivor's position relative to the new starting point, the person after the one eliminated. When you map this back to the original circle of n people, the positions are offset by k. Because the final answer must be a valid index in the original circle, which has n people, you use %n to wrap the result into the range 0 and minus 1. Using n %n minus 1 would incorrectly restrict the result to the smaller circle size, which doesn't account for the full indexing of the original problem. So the shift by k adjusts for the new starting point. %n ensures correct wrapping in the original circle. So whether occurrence uses mod n, not mod n minus 1. Oh. Interesting. Is this correct reasoning? I can see how I might use mod n minus 1 to wrap to the correct index in the smaller circle. In order to map back correct same index in the larger circle, seems like I would need to convert value back by adding n and then adding n minus 1 and then taking mod n. Is that fair? No, that reasoning is not correct. Do not add n minus 1 or use n minus 1 to map back. That's why. Solving this smaller problem, the result gives the survivor's position a circle that was originally position k. To map this back to the original circle of size n, you add k to shift the index forward and then take mod n, not mod n minus 1, because the final position must be valid in the original n-person circle. Using %n minus 1 would incorrectly restrict the result. Smaller circle size can give wrong indexing wrapping occurs. Okay, but is this logically sound? Wouldn't the subproblem need to wrap by n minus 1 to get the correct index in the smaller circle? I would then look to convert that index to the same corresponding index in the larger circle. That makes sense. Huh. No, your reasoning is not correct. Okay. The subproblem of size n-1 is solved independently, and its result gives the survivor's position relative to the new starting point. The person after the one with this position is already computed using mod n-1 within the subproblem. When mapping back to the original circle of size k, you add k to shift the index forward to align with the original numbering, then apply mod n, not mod n-1, because the final answer must be a valid index in the original circle. Do not add n-1 or use mod n-1 at the final step. The recurrence correctly handles the reindexing. Okay. So f of n-1k would already have index that correctly maps into the smaller circle. Adding k would shift that index in the smaller circle. However, in order to be correct index smaller circle, that value would need to be mapped by mod n-1. Are you with me so far? Yeah, there's like a little bit here that I'm missing. It's important. No, you're not correct. Gosh darn it. Okay, I think you misunderstand me. If I wanted to compute f of n-1k from a shifted index, how might I do that? Handled outside the subproblem. Okay, I don't think you understand. That's what I'm getting. If I solve f of n-1k, but from a shifted index, solution to that problem would be f of n-1k plus k mod n-1. In this case, I'm not looking for it. You're able to follow me. Something that LLMs do is that they get kind of hung up on previous prompts and they don't follow you. No, not the shifted subproblem. No, not a shifted subproblem. Just a shifted problem. Are you able to follow me? It's not following me. It's not able to follow me on this one. It's annoying. No. Okay, let's try again. I'll open a new. All right. It's not able to follow me. Yeah, it gets kind of stuck. Have question. Consider the Josephus problem. Wanted to solve f of nk from a shifted index. What would you suggest? Okay, but couldn't I shift the index by just adding alpha or x and taking modulo n on the result? Okay, got it. Yes, so recalculating solution, just adding, taking modulo n, it's appropriate, correct, shifted version of problem. Yeah, so if I just refresh the context, now it understands what I'm trying to explain to it. Yeah, okay, now it understands. Got it. Okay, great. Now, the problem I have is understanding how the recurrence relation comes about. Understand solving the subproblem given index by solving f of n minus 1 k plus k mod n minus 1. Shifted subproblem as mentioned above. This makes sense. Solving the problem in its shifted form. However, there is a need to map resulting index, which is found in the smaller n minus 1 circle, back to the correct index, corresponding index, in the larger n persons. Are you with me so far? So this is what I'm confused about. The shifted subproblem, it would just be modulo n minus 1 for the index. Add k, take mod n minus 1. But that index has to be mapped somehow back to the original larger ring. Okay, so how can I move from moving from f of n minus 1 k plus k mod n minus 1 to the correct index in the original larger circle? You suggested taking mod n instead of mod n minus 1, but mathematically it's not obvious to me. That will always yield correct corresponding index. Are you with me so far? I mean, maybe that it is actually just always gives you the right answer. Oh my god, it's doing the same. It's getting it wrong again. It's so frustrating. Please, begging, begging. Please follow my logic here, reasoning here. Correct index for the shifted problem is definitely f of n k plus k mod n. as previously discussed. However, things get more complicated considering mapping back from a subproblem. Oh, this is so frustrating. Something that I'm confused about, not confused about, but uncertain about. This is very important part of the recurrence relation here. Mm-hmm. Okay, I understand why. Understand the condition under which taking mod n instead of mod n minus 1. But I'm interested in proving that this is the correct thing to do. Mathematics. Do you understand? Like, it's not obvious that that's the correct thing to do. Like, it seems like it's the right thing to do, but why, right? Like, why is that? Yeah, this is like, using AI is just so frustrating. It's too dumb, man. It's too dumb. It might have the knowledge, but it's like not smart enough for you to just ask and be like, here, can you give me a proof of this? G of n minus 1k with this forms. It just keeps repeating the same thing over and over again. This is so annoying. So mapping it, this doesn't really make sense. This only gives you the solution to the subproblem shifted by index k, which is fine, but it's not necessarily the solution to g of nk, I guess, sort of. It's really confusing. All right, let's try. Okay, let's try. Try to map this. If I resolve subproblem f of n minus 1 k, and I add k, I can then take mod n minus 1 to get index of the result shifted problem in the smaller circle. Okay. From there, index is there. I would want to map that index back to larger circle. So I'm gonna have to think about this like on my own. The AI is just gonna keep like chastising me about trying to understand this and basically keep reasserting that its answer is correct, regardless of whether or not I agree with like the logical path that it's taking to that answer, which is really frustrating. Yeah, no, AI is not really that much fun to deal with at times. All right, so let's say I get the in the on the smaller circle, I get the index of the shifted problem. Okay, like I can get that index. That's going to be modulo n-1 though. In order to map this back to the larger circle, I have to think about it. Smaller circle contains all of the same indices. The larger circle, except it's missing position K. It's missing position n-1. Smaller circle is, 0 to n-2. In that case, all of the indices map directly into the larger circle, except n-1, position n-1. Hmm. No, I understand that you keep repeating the formula that's out there. Trying to reason out why that formula is correct. Keep repeating things. Not able to easily verify step by step. It's mentioned. It's definitely true that f of n-1 k. I'm so annoyed. So irritated. It's just gonna keep repeating the same thing over and over again. It's just stuck in a loop. It's not worth trying to. I'm aggravated. It's aggravating. Okay, that's not particularly helpful with what I'm trying to do. All right. No, I want to understand. I want to understand how I can map from a shifted subproblem back to the larger problem index. I know for sure I can obtain shifted subproblem index as f of n-1 k mod n-1. Excuse me. I want to reason out the operations form on that index. Bring it into the larger circle index. Only difference between the two circles in terms of indices is that the larger circle has index n-1, the smaller circle is missing index. And the AI is just going to be like, well, I don't really care. Here's the reasoning for the Josephus problem. For like the 10th time. It's just going to keep repeating the same thing over and over again. Because it's not going to be able to handle that. It's very irritating. Okay. No, I want to stay in a smaller circle, then understand how that index relates to the larger circle. In terms of reasoning, can be absolutely certain that the index of the smaller circle is correct as computed. Cannot seem to follow me on this. It's so frustrating. It's so frustrating. It just keeps going over and over again in like a loop. It's very frustrating. No. Don't map it back. Original circle. You don't understand what I'm asking. This is very frustrating. No, not. All right, forget it. Oh god, dude, this is driving me nuts. This is really frustrating. Very good. Hi, cool alien. What's up? What's up, cool alien? What's up, and Dial Gupta? Watch me just. I'm getting like rage baited over here. Yeah, the question's really simple. I'm just trying to understand why, because I know for sure the smaller circle, the subproblem, it's shifted by k, and I could take modulo n-1 to get the correct index of the shifted subproblem. And like, that's great. But the problem is looking for the index in the larger problem, not the subproblem. And so the general solution, what they say is, we'll just take modulo n and you're fine. And that seems to be correct. However, it's not obvious why that's correct. That's the issue, is the why. And the AI just keeps giving me the how. It just keeps saying over and over that this is how you do it and this is correct. And I'm like, no, you don't understand. I'm trying to understand why it's correct. And it gives me these answers like as to why it's correct that may or may not be true, but it's not the line of reasoning that I'm trying to take. And I'm trying to suggest to it like, hey, you should be able, if it's correct, you should be able to take the smaller subproblem index and just convert it to the larger problem index. And that formula should resolve to the answer that it keeps repeating. But it just keeps it keeps going off, and I have to keep trying to push it back, and it won't go back, and I can't get to like what I'm trying to do. It's very frustrating. It's extremely frustrating. No. You're not getting it. You're not able to follow me. Forget it. It's too much. No. All right. New conversation. It's just like it won't won't stop. Trying to get it to like just stop, and it won't stop. It just keeps trying, which is like, okay. Okay. I have another question. They're good. It's good for knowledge. Like it's good for information that's out there on the internet. It's not really that good at like helping you reason through something in your own mind, right? Like because I'm trying to reason through like things that I know for sure are true. Like there should be a way to do this, and the AI is like it's getting so hung up on. I don't know. I don't even know. It repeated some things that may or may not be correct, but like I'd have to verify if those things are even correct and whether or not that answers my question and so on. It's just okay. How are we doing on time? You watch me just get aggravated with AI. All right. Let me try again. So let's do it myself. Just do it myself. So I've got the reasoning goes, you've got this f of n minus 1 k plus k. And you could take this modulo n minus 1 to wrap back into the indices of the smaller subproblem. That's fine. Now, these should all match. Like if you had a circle of, I guess, 0, 1, 2, and 3. Let's say 0, 1, 2, 3. You have circle 0, 1, 2, 3. And I eliminated one element and then shifted, right? The issue there is, excuse me, when I eliminate that index, that can't be the answer to the result. I think, I guess, the survivor. Well, it eliminates k minus 1. Eliminates k minus 1 and starts at k. So, like, when k is 3, 0, 1, 2. 2 is what gets eliminated. So, it'd be 0, 1. Instead of 2, it would be, instead of 0, 1, 2, 3, it would be 0, 1, 3 are the indices. Now, when I resolve the Josephus problem for n minus 1k shifted, I think that solution is always going to eliminate that the node that I just removed. Yeah, the node that was just removed is always going to be gone in the subproblem. So if I had 0, 0, 1, 2, 3, and I eliminated 2 and started at 3, one of the issues I'm having here is that like the indices into the smaller subproblem don't really map nicely back, or not obviously back. It's not obvious how they map back nicely to the original subproblem. 0, 1, 2, 3. I'm so annoyed. I'm so annoyed that I can't just ask the AI about this. It keeps not answering my question. 0, 1, 2, 3. 2 has been eliminated. Now you're looking at a subproblem with 0, 1, 3. Yeah, it seems like the index that I get after that, when I shift it and modulo the value, quite frankly, if it's smaller than k, so let's say smaller than k, maps directly. Larger than k maps to k plus 1. Or So let's say result or R. Let's say R less than K. If we say K is 3, 0, 1, 2 is eliminated. If it's less than K, maps directly to R. R larger than K or equal to K maps to R plus 1. Yeah, it's an odd thing, huh? I'm not sure about that. 0, 1, 2, 3. Eliminated 2. Now the indices are 0, 1, 3. If the index that I return, so I would shift by 2. I would get some index for 0, 1, 3, but starting at 3 rather than 0. So I would add K to whatever result I get to denote that's a shifted index. And then so let's say if my result was like it's a little confusing if K is 3 and so is like the size of the. I can maybe use K as 2 to make things a little bit easier. So if it's 0, 1, 2, 3, and I eliminate 1, and I start off at 2, so I have 0, 2, 3 now. 0, 2, 3, these are different indices from 0, 1, 2, right? Calling the subproblem f of n minus 1k is going to operate on the 0, 1, 2 case and give me some result between 0, 1, and 2 in that range, or in that subset, or in that set rather. Adding k, which I said was, in this case it's 2, so I would add 2 to whatever I got, so it'd be 0, 1, 2 plus 2 becomes 2, 3, or 4. So I get 2, 3, or 4 for these nodes. If I take modulo n minus 1, that'll map back to 0, 1, or 2. Yeah. Really be 2, 0, 1, I think. And that would be the corrected shifted subproblem and shifted result. That's fine. The problem with that, though, is that my solution, as I mentioned, the indices are now 0, 1, 3, or excuse me, 0, 2, 3. And so you have 0, 1, 2 maps to 0, 2, 3. Values less than k. K minus 1 is eliminated completely. And so R less than K implies R in the larger mapping, and R greater than K, greater than equal to K, maps to R plus 1 in the larger circle. Okay, this is kind of what I was trying to get at. I was hoping the AI could like help me reason through this a little bit, but it could not. So it would map to R plus 1. Now, considering f of n minus 1k plus k mod n minus 1 and f of n minus 1 k plus k mod n comma, does this mapping hold? Okay. And the answer is, I'm not sure. Well, when adding k, values will be more like 2, 3, 4, k equals 2. So naturally, all of the indices exceed k, at least initially. That means these indices be in the r plus 1 case, rather the uppercase. If I take mod n rather than mod n minus 1, what do I end up with? 2, 3, 4 becomes mod n, we said was 0, 1, 2, 3. It's mod 4. Becomes 2, 3, 0. Indeed, 0, 1, 2 maps to 0, 2, 3. And this appears to hold when utilizing mod n. Okay, so yeah, so we would get add, so plus k, we get 0, 1, 2 becomes 2, 3, 4, mod n, get 2, 3, 4 becomes 2, 3, 0, thus 0, 1, 2 maps to 2, 3, 0. Note the original formulation was solving the subproblem of 3 persons, k equals 2, when the I equals 1 person has been removed. And the starting point shifted, start at I equals 2. Then a solution at I equals 0 means a solution in the larger, or the larger circle at I equals 2, I equals 1 in the smaller circle yields a larger circle solution at I equals 3, and finally solution smaller circle at I equals 2 corresponds to a solution in the larger circle, I equals 0. Right, so we shifted over by 2, meaning we're starting at I equals 1 is removed, so the I equals 0 in the subproblem that wasn't shifted should correspond to I equals 2. Then a solution at I equals 1 should correspond to the next value, which is I equals 3, and then I equals 2 should come back around to 0. Okay. Interestingly, these solutions do directly correspond original indices in the larger circle, even if it's not obvious. Yeah, it's not obvious as to why. So this is the, I guess, the solution modulo n minus 1 already. And if I add k and take that mod n minus 1, it's going to be, I guess, wrong. But not just wrong, like it's going to not be, it's n is 4, right? So mod 3 is 2, 0, 1. It's going to be quite a bit wrong, actually. It's going to be really wrong. But it's not obvious at all. Like, and somehow I would want to map this 2, 0, 1 back to the mod n case, which it's not that easy to do that, I suppose. In fact, I don't know if I can easily do that. Yeah, I don't know if I can, in truth. Yeah. I basically would need to apply a mapping from these indices to the other indices, which the mapping is larger to smaller mapping. It's going to be 0, the larger one, 0 to 3 maps to basically 0, 1, 2. So 0 would map to 0. 2 would map to, or really, yeah, so it looks like 0 maps to 0. So 0 in the smaller mapping would map to 0 in the larger mapping. And this ends up not being correct, actually. I suppose the AI would not be able to help me, actually. The direction that I was trying to take that, the AI would just not be able to help explain this as to why this works. These are the indices in the larger, these are the indices in this larger mapping. And the indices in the smaller mapping be, like if I get this result 0, 1, 2, I'd want to convert the 0 in the small map. So I take this mod n minus 1, the 0 in the small map corresponds to, well, it's also shifted. With a shift. With a shift, actually is a little bit more involved. So 2 corresponds to 0. 3, 0. This is the correct correspondence. I'm starting at 2, so that actually should be the resulting 0 with a shift, yeah. So if my result in the smaller mapping gives me a 2, that should actually correspond to a 0 in the larger map. Yeah. Okay. And this is before the shift though. That's really confusing. Oh man. Oh man. Okay. Boy. All right. Let's try. Let's consider Josephus occurrence relation. So I guess the answer to my question is let's look at this mapping again. I don't really need all this. Get rid of all this. So basically, mapping the subproblem nodes to the mapping the subproblem nodes to the original nodes looks like the following. So 0, 1, 2. And it's going to be starting at node 2 and then wrapping around. Interestingly, this is exactly sort of f of n minus 1 k plus k mod n. Plus k becomes 2, 3, 4. And then mod n. Two, 3, 0. Okay. Let's consider a more general case. 0, 1, dot, 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 to n minus 1 maps to so we eliminate k minus 1. So it's going to be 0, 1, dot, 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 k minus 2, k plus 2, dot, 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 n minus 1. This actually should be n minus 2. Yeah. And this is going to be shifted starting at I think it's actually k. If k is 3, we would eliminate 0, 1, 2, and start at k. Yeah, so we start at k. K plus 1, n minus 1, and then 0, 1, 2, k minus 1. Okay, this is the mapping. And if we take 0, 1, n minus 2, and we say plus k, then we get k plus 1, to k plus n minus 1, to, k plus n minus 1, k plus n minus 2, and then mod n gives us k plus 1, n minus 1, or no, excuse me, k minus 1, k minus 2. Okay. Zero. Actually, eventually becomes 0. Oh, excuse me, n minus 2 to 1. Yeah. Eventually gets you to 0, 1, 2. Well, let's come back to that. So it'll be k minus 2. K plus 1. Eventually goes to 0. There's an n minus 1 here, and then 0, 1, k minus 1. Okay. This is somewhere in here is like n minus k plus k or something like that. Somewhere in here is n, basically. It's n minus 1 and n. And then goes to 0. Or excuse me, yeah. N plus 1. N plus k minus 2. Yeah. Okay. Okay. Yeah. So a little bit confusing, but when I add k, so this is what I'm trying to map to. When I add k to this amount, I end up with this sum where eventually I get to n minus 1, n plus 0, and then adding smaller, like some values less than k until I get to n plus k minus 1. And then when I take this modulo n, this ends up being n minus 1, 0, 1, all the way up to k minus 1. Excuse me. And there is a little bit of a jump here too. This only goes up to n minus 2. So this is actually, this should be minus 3 and minus 2. There's something missing here. It's important. Uh, it's not k minus 1 here, it's k minus 2. K minus 1 is gone. Yeah. Okay. So this does map exactly to what we're looking for. Okay. Okay. Uh, yeah, and there's this in between. So you do get k to n minus 1, and then abruptly jumps down back to 0, and then this goes up to k minus 2. Okay. Okay. So in the general case, is a bijection between 0 to n minus 2 and k to n minus 1, 0, k minus 2, which maps the subproblem indices to the shifted larger circle indices as desired. Okay. This is kind of what I was looking for. I mean, maybe I was trying to explain it, but this is very frustrating. So there was not an easy way to explain this, and not an easy way to go from the subproblem indices to the larger problem indices. It kind of just so happens that taking add k and taking modulo n can be shown to yield the correct mapping. But it's really not that obvious. Okay, that took me a really long time. But yeah, that's part of the Josephus problem. That's really not an obvious thing at all. I don't think that's that easy to come up with that. You got to kind of really inspect this to see it. But this formula gives me exactly the mapping that's required for all n and all k. I'm not sure if this is exactly a formal proof, but this is probably, you could formalize what I've written here and show that this is a proof. This is a proof. But yeah, this is sufficient for me to understand it. So this is good. This is kind of what I needed. Maybe the AI was trying to explain this to me, but I just kind of wasn't grasping it. But yeah, anyway, so there you go. That's what I need. Just now ended my stream. Oh, very good. Hey, very good. You saw that string to number medium question? Sure. Was that the one you suggested before? 3889. Solve string to number medium question. Which one is that? So we'll look at 3889, but yeah, this is the Josephus problem. I really struggled with this. My goodness, did I struggle. Got another 30 minutes or so. So this is the generalized Josephus problem, and as it turns out, this recurrence relation, taking the subproblem plus k modulo n works, and then you can invert that subproblem. You can go backwards, and you can do result plus k mod. And you can go up. You can go in the. You can do this to solve this iteratively rather than recursively, and that works. Okay. That took me a really long time. So Which problem exactly were you thinking? Also, let's see. Someone wanted 3889. Let's take a look. Let's take a look. My computer is really laggy. That's probably enough for the Josephus problem. Oh man, that was a rough one. Let's see. What does this have? Except pretty high acceptance rate. Okay, this is on the easier side. Given a string S consisting of lowercase English letters and digits, for each character, its mirror character is defined by reversing the order of its character set. For letters, the mirror of a character is the letter at the same position from the end of the alphabet. For example, the mirror of A is Z, the mirror of B is Y, and so on. For digits, the mirror of a character is the digits at the same position from the end of the range 0 to 9. For example, 0 to 9 mirrored is 1 to 8, so on. Of 0 is 9, 1 is 8. Each unique character C in the string, M be its mirror character. Let frequency of X denote the number of times character X appears in the string. Compute the absolute difference between their frequencies, defined as frequency of C minus M. Frequency of C minus frequency of M. M, each unique character, its mirror character, frequency, number of times appeared in the string. So absolute difference of their frequencies between the character and its mirror. The mirror pairs are the same and must be counted only once. Okay, got it. Return an integer denoting the total sum of these values over all such distinct mirror pairs. Okay, I mean, this is a fairly straightforward question. We'll just have digits and characters. The mirror frequency is a little bit odd, but this is pretty straightforward to calculate. So we'll go through this. You just utilize frequency maps for this. So static int frequency digits, frequency D, digits are going to only have 10 of them. 0 initially. We're going to fill frequency of D with zeros. Frequency maps are definitely, I think I can do 2 of these, and then we're going to do frequency of character, frequency C, frequency D. Also 0. Definitely a little bit easier for me to work with frequency related questions. And we're going to go through const, char, ch, s, frequency D. So if, so you can actually do it even easier than that. You do frequency of D. Also, my computer is really laggy. Plus equals, the character is greater than or equal to, are these, I think it's all lowercase, they said, right? Just double check. It's lowercase letters and digits. Okay, so if it's a letter, actually, I should use an if statement here. Yeah, there's a slight thing here that happens. Yeah, okay. So just check that it's a letter. Then we're going to increment the frequency of D. And it said something about the mirror frequency. We'll come back to that. And if it's a digit, do something very similar. Frequency of, frequency of C for the characters. All right, now, I could just divide by 2 at the end. I could just count everything and divide by 2 at the end. That's probably the easiest. Hopefully this fits in an integer. I think the frequency is only like 50,000 or something. What's the frequency? 500,000. Can I do it like this? I think, yeah, it's a lot less than a billion. Yeah. All right. We'll come back to that. We'll just divide by 2. Oh, bit shifted. All right, let's do frequency of C of I minus frequency of C of some other of the mirror, and then frequency of D of I minus the frequency of D of the mirror. So the mirror is going to be 26 minus I minus 1, I think, for characters. And it's going to be 10 minus I minus 1 for digits. So if I is 0, yeah, that's going to be 9. 10 minus 0 minus 1 is 9. If I is, for the digits, if I is 0, meaning A, 26 minus I minus 1, 25 is Z. Yeah, that's correct. I think that's it. I think it's that straightforward. Oh, okay. Wait, what? Unqualified ID? Oh. I was like, there's an int being defined there. What's going on? Yeah, I think that's it. It's pretty straightforward. Okay. Yeah, fairly efficient. Might be a faster way to do this. Oh wow. Not the most efficient though. It's pretty close to 100%. I guess it kind of varies. This is a reasonable solution. Yeah, okay. Let's do something else here now. I was so hung up on the Josephus question that I forgot what I was even doing. I still got another half an hour. Yeah, I can keep going. That's fine. So that was the solution. Someone asked about this before. So that's this one. Let's go back to the problem list. Let's just keep going through problems. Yeah, I spent a lot of time on that Josephus question for sure. Let's give it a minute. Gotta go find a problem to work on. There we go. Okay. Okay, next. A number after a double reversal. Let's see. Number after a double reversal. Reversing an integer means reverse all its digits. Okay. Leading zeros are not retained. Integer num, reverse num to get reversed 1, then reverse reversed 1 to get reversed 2. Return true if reverse 2 equals num. Otherwise, return false. Basically, if this is divisible by 10, so return num mod 10. It's not equal to 0. I think that's what I need. 0, return false, expected true. And num is not equal to 0. Or num equals 0. Yeah, so it removes the leading zeros, which means it's just if it's, so like 10, 11, 101. Yeah, I mean, I think that's it. I think it's real simple. It's just whether or not you've got a 0 in the, yeah, that's pretty straightforward. I don't think I have to explain that one. That's pretty simple logic there. Execution of all suffix instructions staying in a grid. There's an n by n grid with the top left cell at 0, 0 and the bottom right cell at n minus 1, minus 1. You're given the integer n and an integer array start position, where start position equals start row column, start column. Indicates that a robot is initially at cell start row, start column. You are also given a 0 index string s of length m, where s of I is the ith instruction for the robot. Move left, move right, up, move down. Robot can begin executing from any ith instruction in S. It executes the instructions one by one towards the end of S, but it stops if either of these conditions is met. The next instruction will move the robot off the grid. There are no more instructions left to execute. Return an array answer of length m, where answer of I is the number of instructions the robot can execute if the robot begins executing from the ith instruction in S. Okay. Only one before it's off the grid. All 5 can be executed in the grid. Ends in 1, 1, 0th, first, second. All 4 instructions. Oh, I think I understand. I'm not sure if I really understand what they're asking for here. M, N, M, less than or equal to 500, start position like this, 2. The starting row, starting column consists of left, right, up, down. So I think it's basically asking how far can I go in each of these directions before it goes off the grid. Huh. Number of instructions the robot can execute if the robot begins executing from the ith instruction in S. Interesting. Well, what's interesting about this is each of these instructions modifies its position by adding an amount to it, which means, and addition is commutative, which means that these instructions can be performed in any sequence and I'll still get the same result, which means I can use a prefix array to give me basically I can go right to left using a prefix array to give me an idea of whether or not in fact, I can actually just run these backwards and it'll give me what I'm looking for. Although, yeah, not quite. Well, if I go up, it'll move me off the grid. So then I can say, can I go left? That's interesting. This is interesting. I'm trying to optimize this. I could just run through each one of these, but so this one will move me up and I'll end up off the grid. That means the next instruction is where I want to start. And then so L is possible. Then I can go down as well. and the up actually corresponds to the down. And so it kind of re-enters. So I guess I could push it onto a stack and then pop the stack when I see a corresponding value, an increment. I could use a stack-based solution. Yeah. Yeah, so I could convert its original position to like ups and downs or something. Push those onto the stack. Instead of a stack, I could have a count. So I could have ups and rights or something. And when I see these values, I could add or subtract. And I can modify the total count. Moving right to left. I think I could use like a state machine to solve this efficiently in linear time. And I would just need depending on its position relative to the borders, that would give me the number of rights or lefts that are possible. So yeah, could just do a row column where it's in starting position. Okay, let's try something like this. What is n? Oh, it's the grid size. Okay. Got it. Okay. Okay. So okay. I think I can destructure this. I'm using the word destructuring. I'm not sure if that's the right expression. It's not valid syntax. Structured bindings, excuse me. Can use structured bindings. Okay. Const auto. All right. Not destructuring. It's structured bindings. And I could use references. Okay. Structured bindings. Not destructuring. You use auto for structured bindings. Okay. All right. So Um, what's interesting here is when I see like an up or a down, right? Like if I see those up down pairs, I can actually negate them. Um, I can maybe use H and V, horizontal and vertical. And we would say if CH, it could be up, down, left, or right. So up my horizontal amount, I think is going to be incremented, vertical. And we're going to say it decrements the rows. Down is going to be incremented. And then left is horizontal. Decrement the column. And right, we're going to increment the horizontal side. Okay, why is that meaningful? Well, I want to know how many commands I can add. Um, hmm. Um, that's kind of tricky, huh? Mm, maybe it's better to do something like this. Just increment these frequencies and then perform an application of things of sorts. So if really we want we'll push back this value. So let's see what I get. So if I do the row and the column, so if the row plus frequency left, or excuse me, minus frequency left, plus frequency right is greater than 0, If NR is greater than 0 and NR is less than N, then we just value plus equals frequency left plus frequency. Right? I mean, it's that simple. It's that simple. But there's a little bit more to it than that. These are kind of the this doesn't really make sense, does it? Yeah, this is not that easy to do. I mean, I could just simulate this, but the issue I'm having here, there are a few issues that come up. One of the problems here is that even though these frequencies might be, helpful, they're only helpful to an extent because it's possible that basically some sequence of operations pushes me out of bounds. Some sequence of operations is going to push me out of bounds anyway, and I won't be able to like properly handle all the other instructions. And so this actually doesn't even make sense sometimes as well. It might be easier just to simulate this. This might be a little bit more complicated to not simulate it. There might be a way to do it without simulating it. I'm trying to figure out how I could do this without simulating it, but I think simulating it's probably the only way to go. Simulating it probably is the only way to go, quite frankly. So I think I'm just going to do that. I think I'm just going to do that. Let me go ahead and there's something I want to tinker with here in one moment. Okay. Yeah. All right. I mean, okay. Yeah. All right. I don't really like it, but it's not the worst. It's definitely a lot easier to simulate this. Excuse me, but it could be something better. Okay. Oh, boy. Um, hmm. Mm, um, I'm not sure about this actually. Okay. Hmm. Okay. Hmm. Yeah. I mean, I don't really like doing it like this, but it's not the worst. Okay. It's something like this. Oh. Hmm. I don't think I can use structured bindings on a vector. Okay. No. How about step time? I think it's just default. No. Okay. There was a proposal to unpack vectors. Interesting. Okay. Oh, runtime error. Okay. Wasn't expecting that. Hmm. Why am I getting a runtime error? What's going on there? Um, hmm. 0, 1, 2, 3. Runtime. Why? Oh, yeah. Okay, that's my mistake. Roll. Okay. Of course. Okay. 2, 5, 4, 3, 2. Oh, yeah, this doesn't really count it totally correctly. There's a slight mistake where I'm exiting when, so I increment the value at each position that I'm able to reach. So this should actually be value -1. Although that doesn't give me the right answer for some of these. Because it includes the starting point. Yeah. So it's always going to give me 1 for the starting point, and then make a move. And if I'm able to reach that area, it'll give me another +1. And it'll keep moving until I get to a point where I can't move anymore. Oh, man. Okay. Really, you should just have this bounds check. Maybe I'll just put it at the end. It's something like this. What in the world? I got a -1. What? Oh. Let's see. There we go. That follows the logic a little bit better. All right. Not ideal, but not terrible. There are probably better ways to program this. And I bet you could do it in linear time as well. I'm kind of tired though. A little tired, getting towards the end here. Yeah, I'm not sure if I want to try to sit and figure that one out. We could analyze another solution someone else had though. Spend a few minutes doing that before we go. That's not a bad call. CURP1, CURP2, P1 vec, P2 vec. Huh. Oh, they used unordered maps. Oh, that's interesting, huh? Used a hash map. Well, that's interesting. I didn't think about doing that. Huh. Yeah, I think this is linear time. It's more efficient. Okay, so use a mixture of dynamic programming with hash maps. I wasn't expecting that. Okay, yeah, I mean, if I use quite a bit more, quite a few more data structures, it looks like I can do this in linear time, but it's definitely a lot more involved. All right. Yeah, I need to sit and think about that for a while. Let's see what, like how I could, oh, excuse me, how I could save information, I guess, on the path I've already taken. To optimize. Yeah, I'd have to ponder that more. Let's do another question. I can always come back to this one and think about a little bit more about what I could do to make it better. Distinct string is a string that is present only once in an array. Given an array of strings array and integer k, return the kth distinct string present in the array. There are fewer than k distinct strings, return an empty string. Strings are considered in the order in which they appear in the array. Okay. 1,000 array strings. They're only of size 5. They consist of lowercase English letters. Okay. I mean, hash sets for this is fine, I think. Use a hash set. Kth distinct string. Okay. Sure. An alternative is to an alternative is to use I'm sorry, my mind is elsewhere. An alternative to using hash sets would be to sort it and deduplicate that way. Yeah. Could also use 26 to the 5th, I guess, as an integer as a key, a base 26 key. All right. So if we find this in S, it's not equal to find, then we decrement K. If K is 0, return S. And then otherwise we just insert S. Something like this. Wrong. Okay. 1, 2. Should it be B? Oh, I see. Okay. We want to remove the ones that are not distinct. Okay, got it. Problem with this is that I want to know what the order is. Hmm. Oh, this is an awkward one, huh? Okay, we could do it this way. This isn't the best way, but this works, I think. That'll make typos. Oh, didn't work. Does it have to be sorted? In the order in which they appear in the array. Huh. Yeah, B should be A. He's not distinct. Okay. This does not work. Right. Okay. Almost had it. Some tricky logic here, huh? Super awkward. Yeah, I mean, this is probably easier. Mm-hmm. How about this one? This might be easier. There we go. Yeah, I don't know. I was trying to like think through ways that could work there that are relatively straightforward, easy to code. This is like maybe not the most efficient way, but this is okay. Gets 100%, so that's all right. What's chat doing? All right, I should get going. I'm getting really tired. Yeah, it might be time for me to get some sleep here. So thank you all for watching. I do appreciate it. I'll catch you later. Like I said, I'm kind of tired. And there's a lot for me to think about. Think if there's anything else I want to say or do here. Yeah, I mean, yeah. Let me stop here. Let me stop here. So thank you for watching. I appreciate it. I'm gonna get going. I'm not sure there's much else for me to say. I'm very tired. I probably should just get some sleep. If you like the stream, don't forget to follow, like and subscribe and all that. And